Okay, this is the third part. So, in order to adapt the EMU train to different operating environments, the Chinese government has designed many different EMU models, and all of these trains have similar composition and characteristics. So here we take the CRH3 EMU as an example to introduce this. So we can see this picture. The EMU is composed of 4 vehicles and 4 toes, and so it's 8, right? So it adopts electric traction and is a transmission mode. It is composed of 2 traction units, and each traction unit is consists of 8 vehicles. This is just 1 unit, right? So it's 1 unit. So it has a good shape, and the power is 80,000 watts. So the electrical equipment is under the vehicle, right? It has converter and other transformer and some. So in 1, 3, 6, 8, it has what? It has a traction motor. It has the traction motor and the traction converter, and the 2 and 7 is the transformer. So this is the arrangement, and then let's do some evaluation and do some post development. So there are many parts. They have they have the high technology. For example, the main security design. The traction drive system of the EMU is composed of 2 relatively independent basic units. Yes, we talked it before. 1 unit, it has 8 cars, right? So when the electrical equipment in the basic power unit fails, the basic power unit can be complete or partially removed, and the other unit can drive the train, right? It has 2 units. And the space. Yes, the space is very comfortable for the passenger, and also outside the train, the most electrical equipment is also installed in the under the vehicle area, and to optimize the space available for passengers. So the equipment and the passengers, so it has a good relationship. And the converter is also high technology. It consists of four chopper, and so you can see this 4QC, right? And also the high voltage equipment. So the high voltage equipment is controlled redundantly. So the 2 power units are electrically connected to each other. So in the event of a fault, the operating capacity of the EMU can be ensured. So also, like the first one, the 2 units is very important. And this power supply system is also very important. It adopts the train line power supply mode, and the power supply equipment distributes in several carriages and supplies power to the main line, right? And traction characteristics and the braking characteristic is doing very well. So except for this very select engineering, there are also other advantages for the EMU tree. So it has the fastest speed, right? So why is fastest? So for example, the average speed of the Beijing and Shanghai, this train reached 320 kilometers per hour, and the continuous operating speed reaches 350. It's the highest speed for the for commercial EMU train. So, but actually, yeah, I mean this is the real speed. But actually, it's designed to get more. It's a higher speed. It's 380 kilometers per hour. So this is the design speed, but we don't need to get to this speed because the 300 and 550 kilometers per hour is enough. So it is the fastest speed, but in the European countries it's also like 240 kilometers per hour. So it's very slow. So except for the fastest speed, it also has the highest density. So yeah, it's easy to understand because Chinese has many people, so it has the highest density. So it also has the largest transportation volume. So it has it's easy to understand because it's very wide, right? It has a wide car body. It's a wide car body and long formation. It's long and it has good performance. So it can have the largest transportation volume, and also it's environmental friendly. Well, why we see this? So the traction power consumption per hour is not more than it's very lower. So it has an environmental friendly design for the power. It can save the power, and also it has a good comprehensive control. It has, for example, we talk about that. It's low noise. It has a low noise and low vibration and low impulse, right? Low impulse and so on. And yes, it has a suitable air condition because the air conditioning system is very good. And it has a high reliability and safety. Yes, because the Chinese EMU system has only, it has one accident. Yes, it's very in 2012, but it's just an accident, just this one, right? It's not really. So let's do some summary. It has very high technology, and this railway system shortens the time and space, the distance between the region and the urban and rural area. It has a huge influence on the Chinese cities, in the Chinese society. And the train is very high technology. It has many good designs. We talk about that, right? So in this license, I use the system engineering method I try my best to analyze it, to use the principle to get to it so thoroughly, and do my best to use the method I learned in this lesson to analyze the system. So it's very good for the future to build a system to analyze the system. I think it's very good. So thanks.